Okay, hello. I'm going to show you a concept now I've been working on. This is based on experience from building implementations like signals and function tree, and basically trying to make the concept of actions better, getting the buggability, and give it a functional nature, which helps you write better code, more testable code, and so on. Because in my experience, I don't see people use a functional approach when it comes to the concept of actions. So let me just explain. Like, an action is usually just a method or a function where you would maybe do something like this: is loading equals true, axials get user, then you get the user, and you would say this user equals user or something. The point is that these actions are responsible for performing the state changes and running the side effects in your application. And there are and it's the same thing with all solutions like Redux. Even though if Redux dispatches actions and all this, the point is that everything starts in a simple function. And that's a problem. One problem is that it's imperative code, meaning that the bigger this function gets, the harder it will be to understand what it's doing. It's also impossible to track what it's doing, like build developer experiences on top of it, because you do so many different things here. You just grab Axios from directly from the Axios package, so there's no way to understand that you're using it. And then there's this thing of making things reusable and composable. It's very hard to discipline yourself to do that when you write imperative code like this. And I'll show you what I mean about this shortly. So one way of improving this is that you could use a concept of observables, observable subject, and then you could say like for each, and then you could do like this state, this is loading equals true, and then do this next, whatever. The point is that observables are really built for value transformation, meaning that you get a stream of values in and you want to produce a new value. And this is a really great concept within programming. And there are libraries that puts this as a first-class thing in a web app development framework, for example, Cycle.js. And it's very, very interesting, but it's not very practical. And it's not how I think we are at least used to think about coding. Because what these actions do is not really, you don't have an output from an action, which an observable is. You have like an input and you produce an output. But an action is just running side effects, being state changes, talking to the server, it doesn't matter. So it would be really nice to have a concept that is functional, but embraces that fact around what we're actually doing in actions. So that is what I'm going to show you. Okay, so let's go to this demo. I haven't given it a name yet, but action something. And by default, you create an action and you can call it, and it doesn't do anything. But let's change that. This is actually implemented in TypeScript, so we're going to do some typing here. So I want this action to receive a string. Now, the reason it doesn't give an error now is because TypeScript doesn't support having like an optional argument that is type. So if you give it, it has a type, or if you have typed it, you require the argument. Maybe someone has a good idea how to solve this. But anyways, if I give it a number, it's wrong. I have to give it a string. So I say hello world, and let's do this value transformation thing, where I map to, let's say text, to uppercase, and we'll save that. Okay, so what we're going to do now is move into the terminal, and we're going to see that something actually happened. So this library is implemented with the focus that it's going, you're going to be able to visualize everything that's going on, meaning that it will have a debugging tool similar to Cerebral, very similar actually, where you will see everything that happens visualized in a really nice way. But anyways, what we see here is that an action started, and the action ID is, for example here, do this. This has like an action ID of 0. And execution ID is like, you can call it multiple times. So every time you call it, it gets a new execution ID. And then we see that we started a map operator. It doesn't have a name, path I will get back to. It has the operator ID of 0, meaning it's just indexing the operators. It's the first operator. And then we see that it ends, and the result is hello world in uppercase. And is async is false. So, but this is exactly what it isn't supposed to do. It's supposed to run side effects. So let's change this around. Let's give it a number instead, and number 1. And what we're going to do is say that we get an ID here, and then we're going to bring in the context. So the second argument to all these operators is the context. And this works exactly like function tree. You define the side effects you want to expose to these action chains from the outside, like as a configuration. And then you can be very specific about the API of your application. For example, I've chosen to create an API provider, as it's called. This API provider can get a post, and it takes a number, and the ID is number. So when we save this now and look again, we see that the action started, the map started, but now we actually have a provider here. So it tells us that the API provider called the method getPost, and the result was this information taken from JSON placeholder. And then it ended, and it actually returned that as the result as well, and it now states that it's async. But let's make it more concrete here. We also want to change the state of our application. We want to set our application in a loading state. So we're not going to use map for that, because we're not going to return a new value. So we use each instead. And we're not going to use the ID here, but we are going to use the state. And the state is loading will now be true. We run that again, and let's have a look. And as we see, the action started. It started on each, and now we actually see mutations here. And this is coming from proxy state tree. So I have provided a proxy state tree to this application. And what we see here is what mutations were done inside this. You see it has the same action ID and execution ID. And what mutations was done inside this function. And it was a set mutation on the isLoading path with the argument true. Okay, so we are getting a ton of information here that can be used in a debugger. But writing your code like this, it's easy. Like, you just create the operators and you just write the code. And it's kind of declarative. But what functional programming actually encourages you to do is to not write functions inline like this. You want to create functions outside. So set loading, and then we give it, we now have to type it to keep, so we have our isLoading state, and we'll do the same with getPost here. Let's grab it, getPost, and now we will say that this is a number because we're actually using it, and context. And as you can see, it's working the same way, but this is the point. Like, you want to create all these tiny little functions with very specific jobs, like changing the state or grabbing a post or whatever, and then you compose them together in this chain. And typically you wouldn't even have this in the same file, because you might want to load, set the loading state related to other things, meaning that you could just reuse this same set loading function wherever you want in your application. And what to take notice of here, the reason we type things up here is not only to make it available here. Like, so when you write the function, you know what is actually here. But when we start using them inside our chains, for example, if I expected ID to be a string, it will actually throw an error, or not throw an error, but indicate an error here, because this chain is actually delivering a number. So this is the important thing, that when you type it like this, they become like generically typed, kinda, and it's when you actually use them, you see if they fit with the chain. But okay, let's create another one. We want to actually set the post as well. So let's set post, and now we should get a post here, and we'll say state post equals post. Okay, cool. And it says that's okay. If this was a string, again, it says that it's wrong. I wanted a post. And if I save, we can take another look. We can see that, okay, after the map, we started an each. It did a mutation on the path post, and you see the argument, and you see at the end, it still has the same result of the post. Meaning that when I hold over here, we can see that this action actually returns a post. Okay, so the reason, unlike function tree, where you have the value through the execution as like props here, is that they are different things. One thing is the value going through your chain, and it had like lots of magical logic related to, if you return an object, it will merge it into existing object. You can pass in like an event here. Like if you do a click, you can pass in an event. It always expected an object, and I don't think that's a good idea. Now you can pass in an event if you want to do that, and you can map it to whatever you want, and so on. And if you want this, if you want to pass multiple values down the chain, just use an object, and then you manually merge new properties into that object. No worries, it's basically the same syntax. Okay, but we can actually do some other cool things here. We can say, just for fun here, let's add a filter here. Let's say filter ID is more than 2 or more than 1, then it should go through. So if I save this now, we see that it executed, it did the first mutation, it started the filter, and then it ended with the filter, and then the action ended, because yeah, there was no what's it called, the not the prediction, but the, oh my god, I forgot the word. What's it called? Oh my god, I forgot the word. Anyways, we check that it's over 1. So if I change this to 2 now, and I save again, you see that it actually runs through it as normal. So that's kind of cool. You can actually stop execution. And we can do this even more complex. We can say, we can use debounce here. So, okay, I only want to make this actually run. I want to use like the latest version after 100 milliseconds. I debounce 100, so let's say I call it twice. Then we'll see here, to scroll a little bit. Okay, so this isn't the best debugging experience, but you can imagine putting this data into a visual tool. So we start the debounce, we start an action again, and it starts a new debounce, and then the first debounce actually ends, which ends the action. This was the first action, execution, sorry. You see execution ID 0. And then the second action, second debounce of the second execution ended, and it returned a value 2, and then it started each and went through and actually performed the mutations and everything. Now it's not only stopping execution that's possible. We can actually do something else here. We can actually fork execution. So let's say that since get post returns a promise, so it might fail. Now typically that would just throw an error and it would stop the execution. But maybe we want to actually manage this. So what we can do instead of map is using try. And try requires a couple of more, it requires a second argument. These two arguments are success, which takes an action, and then you have error, which also takes an action. And what's really interesting about this is when we look at execution now, we see that, let's see, we have each the start of, let's move up. Let's move to the try. So we start a try here, and then there's a provider call there for getting the post, and then we can see that it starts an each on the path of success. So it actually tracks these forks in your execution as well. So try is related to promises, but you also have other types of forks. Like we could do like a when here, where we would say, okay, again, let's use ID. When ID is more than 2. If that is true, we want to do something, and if it's false, we want to do, ID more than 2, we want to do something else. And again, this is tracked, and it shows you the path, and it shows all the nested paths and everything. So that's kind of cool. There's also other possibilities to make these things more dynamic. The biggest problem is really TypeScript, like how to type these things to make it predictable. But anyways, it's a really powerful concept that is definitely coming from function tree. Having this ability is super nice when expressing complex flows. So what I think we see here is a really powerful tool. I think this is a really good way to be able to move people that uses actions, and everybody uses actions. It being in mobx, redux, Vue.js, it doesn't matter. Move them into a functional world that manages side effects. And yeah, and I think this is the way to do it. Have this chainable API, because it's still very simple. Like, it's not as declarative as the signals implementation and function tree, but I think it's a very low cost because it's still very readable, and it's just as composable. And I'm planning on allowing you to actually insert your own operators here if you want to do that, and stuff like that. And it will be like automatically tracked because it just works. But okay, I guess that's what I wanted to show you. I'm kind of excited about this. Just seeing proxy state tree and this working together, it feels very right. So yeah, I guess that's it. Thanks for watching.